Hello, good morning. Today, Teacher Kofi is going to record a video because tomorrow, Thursday, I will not be in school. I have to go somewhere, okay? So this is going to be a short video. I want you to watch the video and you're going to do some worksheet. And number 3, you're going to send the worksheet to me, okay? Let's start first very quickly. So in the next 2 to 3 weeks, we're going to try and understand 3 questions. The first is this: how do objects move? Number 2, why do objects speed up or slow down or don't move? And number 3, how can we control that movement? How can we make things move faster or slower? These questions are important because they will help you to do your first project. We have about 2 or 3 projects. This is project 1, the Marble Run project. There will be 4 students in one team, okay, and you are going to design a marble run like this. There are many examples, okay, different styles. It's going to be 20 points and there will be 4 students in one team. Now you have to control the time or the speed of your marble. It should be between 20 to 25 seconds from start to finish, okay? If your marble can be between 20 and 25 seconds, you pass. If it is not, it's a fail, okay? But don't worry about this project. When you come back to school on site, we're going to start, okay? So don't do it now, okay? Very good. Let's continue. First question, let's start now, okay? So we're going to talk about something. If you look at these 3 pictures, what is same about them? Opening a bottle, pushing a cart, and carrying books. What is the same about these pictures? If you said force, you are correct. They all use force. You have to use force to open your bottle, to carry your books. And this is force in type. Now, what do you know already about force? Now, let's continue to the next slide. Here are some facts about force. Force is a vector quantity. It means it has size and direction, right? We have scalar and vector. Force is vector. And we can measure the force with a force meter. This is a force meter. When you come to school, you're going to use this in class. And the unit of force is newtons. Now, this part of the activity, because we are online, right? We cannot do the lab. You're going to do the line online, and you're going to write your answer on the worksheet. Don't worry, teacher will send you the worksheet in the line group, okay? Now, this is what you're going to do. You're going to play a little online game. This is a tug of war. We have the blue team and the red team. And they're going to use forces to pull the cart. Which team is going to win? Where will the cart move? To the left or to the right? First, there are three parts, 3 setups. Number 1 is you're going to get one big blue guy and one big red guy. Now, before you click the go, you tell Teacher Kofi, what do you think will happen? Will the cart move to the left or to the right? To the blue guy or to the red guy? You write first, okay? When you finish, you click the go and see if you're correct. See what happened, right? So you write it here. What I think will happen, what happened, okay? So you're going to do number 2, 2 small blue guys and 1 big red guy. Okay, and you do the same. What will happen and what happened? Would it move to the blue team or to the red team? And number 3 is one medium blue guy and 2 small red guys. Okay, where would the cart move? Now I will send you the worksheet and the link to play this game. Okay, so don't worry. Next, so this is example. You take one blue guy, one big red guy, and then you write first. You predict, and you click the go. Okay, I will not show you because I want you to do it, and then you write it. Next slide. Now let's talk about net forces. This is net force in time. Sometimes we have 2, 3, or more forces on one object. Okay, and we have to know the sum of the forces, and the sum of the forces is called the net force. Net force. Now, net forces are important for scientists and engineers because when they design things like a rocket or build a bridge or even the school bag, they have to know the maximum forces, okay, or the total forces that will be on the thing. If they don't know, the bridge can break down and people will die, right? So it's important for scientists and engineers. Now, we're going to learn how to calculate the net force. So if you have a calculator, you can use it, okay? You can bring it out. Now, let me go to my PowerPoint to show you that. Here, let's go here. Okay, so how do we calculate net forces? We're going to look at A, when the 2 forces are opposite, they're in opposite direction. Like this example, we have the boy is pulling with 10 newtons to the left, and the other boy is pulling 20 newtons to the right. They are opposite, right? Now, first, to find the net force, we have to draw everything again. We will not draw the car, but you just draw a box. Okay, the box will be the car, and we're going to draw the forces: 20 newtons to the right, 10 newtons to the left. Okay, you can see the arrow 20 is bigger than 10, right? Now let's look at it. What is the net force? When the forces are opposite, we're going to minus. So 20 minus 10, and the net force will be 10 newtons east. We have to bring the direction because force is a vector quantity, right, to the east. Next. B, when the forces are in the same direction, how do we find the net force? Like this, we have 2 men, they are carrying the sofa, 250 newtons and 300 newtons to the right. First, let's draw the forces. Okay, we draw the sofa as a box. Okay, we use a box. And we have force number 1, force number 2. Okay, now what is the net force? When they are in the same direction, we add. Okay, we add. So 250 plus 300 will be 550 newtons east. Okay, bring the direction. Now let's go to the next part. So A is what? When the forces are opposite, we subtract. B, when they are in the same direction, we add. C is when they are at 90 degrees, because sometimes the forces will be at 90 degrees. Like this example, okay? How do we find the net force? First, let's learn how to draw the forces, right? We have 3 newtons to the right and 4 newtons up. This is how we draw the net forces. We draw one of the forces first. Example, 3 newtons, and we draw the next one, the 4 newtons. And we join the head of the 3 to the tail of the 4, head to tail. And this will be the net force. We draw the net force from the tail to the head, the blue line, okay? So we can draw like this, or we can draw the 4 newtons first, and we draw the 3 newtons second, but always the head to the tail, the head of the 4 to the tail of the 3. And we draw our net force from the tail to the head. This is also correct, okay? There are 2 ways to draw, but always from the head to the tail. Now, how do we find the net force? Because we have right angle triangle, okay? 90 degrees, we can use Pythagoras, okay? So Pythagoras is what? C squared is equal to A squared plus B squared, right? A is 3, B is 4, or you can change it. A can be 4, B can be 3, okay? And C is the net force. So let's put everything in. C squared is equal to 3 squared plus 4 squared. And the answer will be C squared is equal to 9 plus 16. C squared is equal to 25. And C is the square root of 25, which is 5 newtons. And the net force is going to be 5 newtons northeast. We have to bring the direction, okay? It has size and direction. Next. So again, when you draw, you have to draw the correct way, right? Head to tail. If you draw from head to tail, the direction will be correct because the direction will be from the tail to the head. But if you don't use head to tail, let's see example. If you draw like this, head to head or tail to tail, now you don't know where is the direction of the net force. We don't know, right? So always draw head to tail. Let's go to the next part. In this part, we're going to learn how to find the net force when the angle is not 90 degrees. 90 degrees, we can use Pythagoras, right? But sometimes it is not 90 degrees. Example here is 120. How do we find the net force? Now, there are 2 ways that we can find. The easy way and the hard way. So which one do you want? I think you want the easy way, right? Yes, but we're going to look at the 2. Sometimes we have to use the hard way in your test, okay? So let's learn both. Let's start with the easy way. So, by the way, before we look at it, let's look at the formula. The easy way, the net force is equal to the square root of A squared plus B squared plus 2AB cos theta. In the hard way, the net force is equal to the square root of A squared plus B squared minus, okay, can you see that? In the easy way is plus, in the hard way is minus 2AB cos theta. Now, let's look at the easy way. So why is it easy? Because in the easy way, this theta is equal to 120. We just look and write. It's there, right? 120 is always in the question. So it's easy. Oh, by the way, did you guys study in math, sine, cos, and tan? Okay, I think some of you have studied. Okay, it's not always easy, but I think you can do it, okay? If you pick your calculator, you can see the cos and sine there. But in the easy way, the cos is equal to 120. So we just put everything in, okay? So like this. So the net force is equal to 3 squared plus 4 squared plus 2 times 3 times 4 cos 120. Now, if you add everything together, cos 120 is equal to minus 0.5, minus 0.5. So this will be negative. The final answer will be square root of 13, which is 3.6 newtons. But we have to bring the direction. The direction is northeast, right? If this force is 4 newtons, this is 3 newtons, the boat will move this direction, right? Northeast. This is the easy way. Okay, let's look at the hard way. So in the hard way, the theta is not 120. It is not 120 degrees, so we have to go and find the theta. This is why it is hard, okay? It is not 120, but let's look at it, how to find it. It's simple, okay? First, let's draw everything again. We have 3 newtons and 4 newtons, and the angle is 120. First step is what? We have to draw, copy and paste the forces. So 3 newtons, I copy and paste at the opposite side. And 4 newtons, I copy and paste it. Why? Because I want to make a parallelogram. Okay, cilium, like this, okay? Very good. Again, let's repeat. What did we do? Copy the force and paste at the opposite side. Copy 4 newtons and paste on the opposite side. And now we can draw the net force. The net force we draw from the 2 tails to the 2 heads. Okay, 2 tails to the 2 heads. Now, when we have parallelogram, cilium, right, there are 2 rules to remember, 2 rules. The first rule is this: the opposite angles are the same. So if this is 120, this angle will also be 120. This is a rule in parallelogram, okay? So if this is 120, this is 120. If this angle is theta, this angle will also be theta, okay? This is the rule. Rule number 2 is all the angles will add up to 360 degrees. So if you add 120 plus theta plus 120 plus theta, you will get 360 degrees. So what do you think is theta? How much is theta? Let's look at that here. Theta is going to be 60 degrees. Why? Let's look here. Let me show you why is 60. So first, everything will add up to be 360, right? So we have 120 plus 120 plus theta is equal to 360. 120 plus 120 is 240, right? Theta plus theta is 2 theta equal to 360. 2 theta is equal to 360 minus 240. 2 theta is equal to 120. Theta is equal to 120 over 2. And then theta is going to be 60 degrees. Okay? Now we can use the 60 degrees here, cos theta. This is why it's the hard way, because we have to go and find the theta. We cannot use the 120. Okay? And remember, this is minus. Okay? So let's look at that. Let's put everything in. If you put it in, we a squared plus b squared minus 2ab cos theta. A is 3 squared plus 4 squared minus 2 times 3 times 4 cos 60. Cos 60 is 0.5, okay? It's positive 0.5. So if you add everything together, we get root 13 or square root of 13, which is 3.6 newtons, and the answer is 3.6 newtons northeast, okay? Because, and you see the green line, this is the net force, is going northeast. Okay, this is the hard way, right? The hard way is good because you can also know the direction easily, okay, right? Okay. Now, why should we use the hard way? Because sometimes, I think in your test, you cannot use a calculator, okay? You have to remember these angles, cos 0, cos 30, cos 45, cos 60, right? Cos 60 is 1 over 2 or 0.5. You have to remember them, okay? And sometimes you cannot use the calculator. So if you have 120 or 150, it's very hard to do. But these ones, easy to remember. Okay, very good. Good job. Now, we have finished. There are 3 questions for you for part B, right? Part A is a online game. You play and write. Part B, I have 3 questions for you. You're going to write your solution. How did you get it? I want to see how did you get it. Okay, don't write only the answer. Number 1, 2, and 3. Okay. Number 3, you can use the hard way or the easy way. It's up to you. Number 2, you have to use the Pythagoras, right? The answer for number 2 is this: 10 newtons southeast. Okay, but show me how did you get it. Number 3 is 15.62 newtons northwest. Okay, very good. Now, I will send the worksheet to you after you finish. Let's go here. Let me show you how to send to teacher. You're going to send to teacher here on the Padlet, just like we did last time, right? You come, I'll send you the link to this also. When you come here, you look for Matthew 2/1 Campaign Pet. You click the small arrow and you write your name, example Kofi, your number 25, and you upload a picture or the PDF of your worksheet. So example, let me, okay. You just upload after you finish, right? And you publish like this, okay? Now, don't use AI, okay? I want you to do it by yourself. It's okay if you're wrong. If you do it by yourself, it's better. Do it by yourself and wrong is better than use AI and get it correct, okay? I want to see you practice, okay? So this is all. If you have any question, you can ask teacher in the line group. And thank you very much. I hope this is helpful. Goodbye, 6-7.